I haven't had coffee yet, so I'm a little bit asleep. All right. Hello, welcome back. 2.1 today, monomials and polynomials. So we are done with chapter 1, moving on to chapter 2. So again, with algebra 2, a lot of what you see is algebra 1 that has been expanded into algebra 2. So when you look at monomials and polynomials, you're going to be doing properties of exponents, which you know already. You've worked with that already. So what happens when you multiply two numbers? You add the exponents. When you divide, you subtract the exponents, and so on and so forth. So again, it's something that you've seen already, so a little bit of it should be familiar. So let's go ahead and get started. Monomials, with that, let's start with that one. That is an expression that contains a number, variable, or a product of a number and one or more variables. So it could be numbers and variables as long as you don't have adding, subtracting. So there's no adding, subtracting. All of monomials are linked through multiplication. So monomials cannot contain variables in denominators, like the one you have right here. So no variable in the denominator. No variables with exponents, so nothing with an exponent that's negative, or variables under radicals. So you can't have that. And obviously, I already told you that you can't have adding or subtracting. As soon as you add or subtract another term, then you no longer have a monomial. You may have a binomial, a trinomial, or a polynomial. So these are examples of monomials. These are examples of terms that cannot be described as monomials because they have certain things that you're not allowed to have if you're describing something as a monomial. So a lot of vocabulary down here you also already know. We know that constants are monomials that contain no variables, so any number is a constant. Then a numerical factor of a monomial is the coefficient, so basically the number in front of the variable. And you know that they're linked through multiplication. So if I have 3x, that's really 3 times x. The coefficient, for example, of negative 6m will be negative 6. Now, the degree of a monomial is the sum of the exponents of the variable. So I'll give you an example, and then I'll expand on it. The degree of 12g to the 7th, h to the 4th, since that is a monomial, there's none of these things that we can have in order to describe that as something that's not a monomial. This is a monomial. When you have a monomial, you also have a degree of its variables. So if you had only 12g to the 7th, that degree would be 7. But because you have 12g to the 7th, h to the 4th, then you're adding the two degrees, the two numbers, and you're giving that as your answer. So the degree of this monomial is 11. Now the degree of a constant is 0. So this is where I want to make a clarification. A degree and an exponent or power are not the same thing. So a degree is only for variables. So notice that if I asked you what degree is 12, no degree, because it doesn't include a variable. But if I said what power or what exponent is 12, that would be 12 to the first. So degree and exponents are not the same thing. So be careful with that. So with that, we're just going to go ahead and start simplifying these things. So remember, through multiplication, these are two monomials that are being multiplied. So simplify expressions with multiplication. And with multiplication, you have basically you're multiplying the coefficients, but you are adding the degrees or the exponents. So you have 3 times negative 4. Very simple. That's negative 12. Positive times negative. You have x to the third and x to the second. You're adding exponents because you're multiplying. So that's x to the fifth. And you have y to the second times y to the fourth. And you're adding the exponents again. That gives you y to the sixth. So that's your expression simplified. And this is still a monomial. So for the next one, remember when you do ST1, that's the one that I want you to try on your own. So that's the example that I want you to try, the one on the right. So you can pause, get it done on paper, and then play to see if you did it right. So same thing with this one. We're multiplying 3 times negative 8, 24. Then you have x to the fourth times x to the third. You're adding the exponent, so that's x to the seventh. And you have y to the sixth times y to the second. You have y to the eighth. You're adding the exponents for like terms or like variables. The second example is about division. And remember that if you need to see the rules, all of these rules are here. I'm not going to spend the time of going over them because these are rules from Algebra 1. So you should know those pretty well. But if you need to, you can go back and look. So simplifying expressions with division is subtraction. So basically, if you're dividing p to the third by p to the eighth, that's the same as having p to the 3 minus 8, right? But 3 minus 8 gives you negative 5. So you end up with p to the negative 5. And we cannot have a variable. We can't leave something and say that it's simplified if we still have a variable with a negative exponent or degree. So we have to use the property that tells you that if you have a negative exponent or a power, right, you have to flip that over. So we have to use the reciprocal of that. Since p to the negative 5 right now is a numerator, that's always over 1, right? If you don't see a denominator, that's 1. Flip it over. So that becomes 1 over p to the 5th. Flipping this over is the same as taking the negative out of the exponent. And that's how we fix that. Now, we started with something that was an expression. We can classify these things are monomials or not monomials, right? For example, this would be a monomial. This would be a monomial, but as soon as you get here, you have a variable in the denominator. So just because you end up with something that's not a monomial, it doesn't mean it can be simplified. It just happened to end up as something that is not a monomial. So I'm going to show you a little shortcut for this one because I want you to think in terms of common sense, right? Also, so this is the rule. The rule is subtraction, and because you end up with a negative, you have to flip it. But p to the third over p to the eighth. Think of this. This is basically 3p's being multiplied on the top, right, to end up with p to the third. And on the bottom, it's going to take a little long because it's 8 of them, right? You have 8 of them. But remember that when you have division or fractions, right, if you have like terms top and bottom, you can cancel the same amount of terms. So think of subtraction. It's still subtraction, but you're going to write the answer where the biggest degree of the biggest power was. So if you cancel these 3 with these 3, there can only be a leftover on the bottom because that's where the bigger power was, right? So that means that you have 1 on the top because you can't leave that open, and then you have 1, 2, 3, 4, 5 on the bottom. So here's the shortcut. The shortcut is we're still going to subtract. Subtract 8 minus 3 is 5. But because 8 was on the bottom, on the denominator, that's where the leftover is. You can't have a leftover where the smallest number was. So it has to be on the bottom. If I were to flip that over, the same rule applies. If I had p to the 8th over p to the 3rd, I could still cancel 3 of them. But because p to the 8th was the bigger number, it was on the top, that's where the leftover is. So that would have been p to the 5th. So using that rule, you have this other example. Oh my goodness, excuse me. Whew, bless me. So you have an example here, 2p to the 5th divided by 6p to the 2nd. So you have, this is the same as saying 2 over 6 times p to the 5th over p to the 2nd. So all of these things, all of these expressions you can undo and redo by multiplication. So undo, simplify, and put them back together through multiplication. So the first part is just a fraction that you can reduce, right? That becomes 1 over 3. The second part, we're using the same rule that we used in the previous example, EX2, but we're going to use the shortcut. If I have division of variables and I have a power of 5 on the top and a power of 2 on the bottom, I am dividing, then that's subtraction. So it's 5 minus 2 gives me 3, but because the 5 is bigger than the 2, that's where the leftover is, which in this case is on the top. So this is times p to the 3rd. So when you multiply that back, when you put it back together, you could write it as 1/3 p to the 3rd, or times p to the 3rd, or you can write p to the 3rd over 3, because you're multiplying 1 times p to the 3rd, that's p to the 3rd, over 3. So either one is acceptable. All right, so moving right along, we have simplifying expressions with powers. So for these, you can work in whatever order you want, as long as you use the properties correctly. So remember, for this one, if you have a power that's negative, to get rid of that power, you can flip this over. So you can do the flipping first, or you can do the power to a power first. So if we flip it first, we basically have 4 over x. The entire fraction is being applied a power of -3 because it's in parentheses, so we know that the entire thing will eventually be applied that power. Now, because we flipped it, then that power becomes a positive. So that means you're applying a power of 3 here and here. So 4 to the 3rd over x to the 3rd. And you can simplify 4 to the 3rd because that's a base as a regular number, it's a constant. So it becomes 64. 4 times 4 times 4. Remember, it's not 4 times 3. It's 4 times 4 times 4. And then over x to the 3rd. Now, notice that this one is also not a monomial because you have a variable on the bottom, on the denominator. So then this one right here Same rule applies. Remember, if you don't see a power, right? Powers are 1 if you don't see them. So you're applying a bunch of things, a bunch of different things you have in parentheses. You're applying a power of 5 to each one. And a lot of students forget to apply it to the constant base. So that base of -2 has a power of 1. So you're taking -2 and bringing it to the 5th power. That becomes, well, let me write it out first and then you'll see it so I don't skip steps. Then P becomes P to the 15th. Power of a power means you multiply. And R becomes R to the 10th. And then the only one that you can simplify will be -2 to the 5th. And that would give you -32. So the entire expression is -32, P to the 15, R to the 10th. All right, moving on. Remember, pause, do it on your own, and then come back. So that first one, this C here, easy, because its power of a power is just multiplication. So that's x to the 18th, and you're done. For D, be careful because you do have, excuse me, a base that is a constant, a number, right? You're bringing -3 to the 4th power. So all of the stuff in parentheses is going to be applied a power of 4. So that becomes -3 to the 4th power, x to the 4th power, and y to the 4th power. And the reason I put -3 in parentheses is because you have a power that's even. So that negative has to be multiplied an even number of times, and that will make it a positive. I didn't have to do that in the previous one because the power was odd. So an odd power with a negative base will always give you a negative number anyway. So you don't have to worry about it when you have an odd power. But with an even power, even when you put it inside your calculator, you have to make sure that you're using parentheses. So your calculator understands that you're trying to also multiply the negative 4 times. So -3 to the 4th becomes -81, and x to the 4th and y to the 4th, nothing you can do because they're different bases. So that's your solution for that one. That's the expression simplified. So now at the bottom, we have simplifying expressions when you're using multiple properties at the same time. And again, you can do these properties or use them in whatever order you want, as long as you understand how to manipulate them. So for example, since all of this is in parentheses, but everything has a power of -4, I can decide to flip over the entire fraction first. Remember that you're not changing any signs inside the parentheses. None of that will change. All you're doing is writing the reciprocal. So that becomes 2 to the 2n power, 5 to the 3rd power, and on the bottom you have -2x to the 3n power. And this one looks funky because you have powers that have numbers and variables, but it's fine. The rule does not change because you have a variable as a power. The rule is still the same. The rule applies. So you have a -4 here, but because we flip this, that power becomes a positive, and that's how we handle that. Oh my God, that looks horrible, guys. Hold on a second. That looks horrendous. Okay, let me fix that. So this is a 4. There we go. So now that you have that, this is basically power of a power. You're applying a power of 4 to every power for every single thing that's in here. Remember that -2 at the bottom, that has a power of 1. So you have to multiply power times power, not based on power times power, power times power. So that becomes 2 to the 8n, y to the 12, over -2 to the 4th. 1 second, let me fix that. See, I said -2 to the 4th. I was already thinking about the number 4, and I almost wrote a 4. So -2 to the 4th, because we have an even power, and x to the, remember, you're multiplying everything, so x to the 12n. So now the only thing you can do here, it's basically simplify that -2 to the 4th. Y and x are different bases. There's nothing you can do about 2 to the 8n. We don't even know what n is. We don't have the value of that. So 2 to the 8n, y to the 12, over -2 to the 4th is going to give you a positive number. And that's going to be positive 16. So that gives you 16 on the bottom, x to the 12n. And some of you think, oh, I can simplify this. You cannot. If you just had 2 over 16, if the 2 didn't have a power of 8n, then you could simplify. So that would have been 1 over 8. But because this one has a power that doesn't match the power for this one, then there's nothing you can do about it. It's not even the same base. So nothing you can do. That's it. That's the final answer. So then the one, ST4, remember, pause, do it on your own, and then come back and check. Same thing, it's a little easier because you don't really have negatives here. So you can do a couple of things. You can notice that you have an m to the second over an m to the fifth. They happen to be the same base, right? And they're being divided because you have a fraction. So you could simplify this before you apply the 3. And I think I like that better. So I'm going to keep the 3 and I'm going to keep the 2. Now, m to the second and m to the fifth, because you're dividing, remember, it's subtraction, but you're going to keep the leftover where the biggest power was. And the biggest power for m is on the denominator. So you can say 5 minus 2 is 3, but that 3 power is going to go on the bottom, right? Then you have, because of that, this m2 is no longer here. That's just an m3 on the bottom. Then on the top is just 3. Now we're missing the n4, and don't forget that, n4. And the entire thing, which did not have to be flipped because you don't have a negative, is to the third power. Now what you're doing is you're applying a power of 3 to everything, including your bases that don't have an exponent or a power. Remember that would be 1. So this becomes 3 to the third. Right? The bottom becomes 2 to the third. M to the, now you're going to multiply powers. 3 times 3, 9. And 3 times 4, 12. And then we can simplify the two constants. So 3 to the third gives you 27. And 2 to the third on the bottom on the denominator is going to give you 8. Remember, it's not 2 times 3. It's 2 times 2 times 2. Then m to the 9th and n to the 12th have to stay. There's nothing else you can do about that. So that's the part about simplifying expressions or monomials, which at the end, you may or may not have, you may or may not be able to describe them or classify them as monomials. So moving on to polynomials. So if you take a bunch of monomials and you link them together with adding or subtracting, you basically have a polynomial. That's pretty much what it is. So each of the terms of a polynomial has to be a monomial. If it's something else, if it's not a monomial, then you can classify those things as any polynomial. They are classified in 2 ways. So you can classify them by degree. You can classify them by using the number of terms. So by degree, a degree 0, for example, will be a constant. And that would be, like we talked about it before, constants don't have a degree. They have a degree of 0. For you to have a degree, you have to have a variable. So degrees are applied only to variables. Now, because this is one term, you call that a monomial. Now, look at linear. Anything with a degree 1 is linear. But if you look at this example, because you have 2 terms, that's a binomial. So this is called a linear binomial. Linear because of the power, or sorry, the degree, and binomial because how many terms you have. And you have 2 terms. Terms are separated by adding or subtracting. So as soon as you throw in a plus or a minus between 2 expressions, you have a binomial. Then if you have degree 2, that would be a quadratic. That's what this is right here, power of 2, degree of 2. And I use them interchangeably, but I shouldn't because degrees are only for variables. And then number of terms, you only have 1. This is all through multiplication. So through multiplication is just a monomial. So this will be a quadratic monomial. You get the idea. Cubic is 3, a degree of 3. Quartic is a degree of 4. Quintic is a degree of 5. So if you have 3 terms, that's called a trinomial. If you have 2 terms, that's a binomial. If you have 1 term, that's a monomial. And anything 4 or over, it would be a polynomial of blank terms. So if you had a polynomial that was 5 terms, you would say a polynomial of 5 terms, but you can still describe it as by degree. So for example, if this had another term, we could call that let's say a quintic polynomial of 5 terms, and so on and so forth. So the degree of polynomial is the highest exponent. We talked about that. Now, when you have more than 1, you would add those exponents, right? And that would be your degree. And exponents are different than degrees. So keep that in mind. I keep repeating it because even I forget sometimes. And I use them interchangeably when, you're not supposed to. So determine, for example, 5, determine if the expression is a polynomial. If so, classify by degree and number of terms. So the first thing is a polynomial has to be made up of terms that are monomials themselves. So you have to check each of the terms. So I would have to check to make sure this first term right here is a monomial. I would have to check that this is a monomial. If the answer to that is yes, then you can classify by degree and number of terms. So is the first one a monomial? Yes. I don't have anything that is not allowed to have for me to classify it as a monomial. So it is a monomial. 9x to the 4th is also a monomial. So it looks like we have 2 terms. So keep that in mind. then the degree for this one would be the addition of 3 and 5 over the 2 degrees that you have. 3 and 5 is 8. This one is only 4. You would always pick the highest degree. Now, anything of a degree greater than 5, we don't have a word for it. We call it degree blank, whatever the degree is. So since this is a degree 8 and there are 2 terms, this is a binomial degree 8. And that's what we write. So when you look at B, 1 over 6 n to the fourth. One of the things we cannot have if we're going to classify, I almost said sacrifice. Oh my God. I haven't had coffee, guys. So classify, if we're get ready to classify a monomial, one of the things that we cannot have is a variable in the denominator. So as soon as you see that n to the fourth on the bottom, the 6 doesn't even matter. It's just the n to the fourth is the problem. This cannot be classified. So this is NA. Remember, for algebra 2, don't leave anything blank. If there is no solution to whatever you're working with, you write NA, not applicable. So then when you look at ST5, on the right-hand side, you have x plus square root of x plus 5. And remember, you are checking each term. So x is a monomial, 5 is a monomial, but the square root of x, automatically, you cannot have a variable inside a radical. So this is NA. No classification here. Then when you jump over to D, you have 1/3 x squared y to the fourth. You can have a constant in the denominator. So that's allowed. What you cannot have is a variable, right? So this one's good. So is this one. This is just a simple, 15x to the 6th. That's a monomial. So we have 2 terms. So it's going to be a binomial. But we have to make sure we check the degree. So this is 2 plus 4. That's 6. This is already degree 6. So if your degrees are the same, if they repeat, you just write degree 6, whatever that degree is that repeats. So this is a binomial of degree 6, because we don't have a name for a degree 6. All right, so moving on to other operations that we can do. So far, we had just been, let me move back up so you see it. We have been simplifying using properties of exponents. So we did that in the first part up to example 4. Then we jumped over to classification, and then we're going to move over to operations. But notice that all we're doing here is adding, subtracting, and multiplying. So division has its own set of rules that we're going to work with in the next notes. So right now we're going to focus on this. But again, this is something that you've already seen in Algebra 1. So I'm going to go kind of quick through this. So basically you have your first example here, subtract and simplify. There's a subtraction between the 2 parentheses. So when that happens, make sure that you apply or you distribute a -1. So you really have 3x squared minus 2x plus 3 minus x squared minus 4x plus 2. So everything behind that negative sign has to change signs. And then you're looking for like terms, and you always start with the highest degree. So highest degree right here. 3x squared minus x squared. Remember, you're just subtracting the coefficients and you're keeping the variables the same. So 3 minus 1 is 2. That's 2x squared. Then you have negative 2x and negative 4x. Combine, again, just the coefficients. Negative 6x. And then you have 3 and 2. Positive 3, positive 2. That's plus 5. So if you were to classify this, right, this would be 3 terms. So based on the terms is a trinomial. Each term is a monomial, right? So this would be a trinomial that's quadratic because of the degree of 2. So this is a quadratic trinomial. So you know what? We could actually, I know it doesn't say it there, but we can classify. There we go. So you can get the practice into. So remember, take a pause or actually pause the video. Oh, I messed this one up. This should be ST6. So remember ST6, you try it on your own. So pause, do it on your own, then come back and see if it's right. But I'm going to go ahead and continue. So we have 10x squared minus 3xy plus 4y squared minus 3x squared minus 5xy. So this one, I would start with either the x squared or the y squared. It really doesn't matter. So we have 10x squared minus 3x squared. So that's going to give you 7x squared. Then we have another quadratic here, right? Power 2. But notice that this monomial and this monomial are also a power 2. So it really doesn't matter in what order you write it. I'll probably write this one first. It really makes no difference. 4y squared, notice that 4y squared doesn't have any other like terms. So 4y squared is itself on its own. There's nothing you can add or subtract to it. Then you have negative 3xy. and negative 5xy. Those two have the same variables, like terms, so that's negative 8xy. So moving on to addition, same thing, but now we're adding. Because you have addition, there's no change in the signs, right? You don't really distribute a positive one. It's not gonna have any effect on the second parenthesis. So all you're doing is looking for like terms and putting them together. By the way, this will be also a quadratic trinomial, the one that we just did. So then add and simplify. You have x plus 4x squared. Sorry, x squared plus 4x squared, that's 5x squared. You have negative 4x and positive 3x, that's negative x. Remember, you're combining coefficients, you're leaving the variable alone. And positive 3 and negative 5, that's negative 2. So you're done with that one. This is also a quadratic trinomial. These are the ones that come out the most because these are the ones that you're going to use the most in Algebra 2, especially when you start factoring. There's a lot of quadratic trinomials. And of course, there's one chapter that's all quadratic. So you're gonna see how those pop up all the time. So same thing here, simplify. You're adding terms. These are two terms only. So you're adding anything that has the a. So 2a plus 8a, that's 10a. And then 3b minus 5b, that's negative 2b. Now to classify this one, each of the terms is a monomial. This is degree 1. This is also degree 1. Degree 1 is linear. So this is linear based on degree. But notice that you only have two terms. So this is binomial. It's a linear binomial. There we go. So then we're moving on to the next one. So this one's multiply and simplify. Multiplying is basically you're either using distributive property, which is really old. You learned that a long time ago, or you're doing FOIL with binomials or with trinomials. It's the same thing, it's just longer. So you're using the same exact method. It might be shorter or longer. So for the first one, remember when you're multiplying or distributing a term outside 2x that has a variable, that variable has a power of 1. When you're multiplying coefficients, but you're adding powers. So this becomes 14x to the third. Because remember, if you don't see a power, there's a power of 1, right? 14x to the third minus 6x squared, and then plus 10x. You're basically multiplying or distributing that 2x to everything that's inside. So 14x to the third minus 6x squared plus 10. Now to classify this one, each one is a monomial. The highest degree is 3, so this is cubic. So this is a cubic based on degree. And because it has 3 terms, that's a trinomial. So this is a trinomial. All right, moving on to be down here. This is still distributive property, but because you have binomial times binomial, it's actually called FOIL. And FOIL just refers to, we learned before, the order in which you multiply it. So you're multiplying the first two terms, that's 15y to the second. The next two, so it's first, then it's outside terms, and that gives you 12y. Then you have 2 times 5y, that's going to be 10y. And I always line them up because it's easier to add them up at the end or to combine them. So these are the inside terms, 2 times 5y, that's 10y, and 2 times 4 is 8. So for your final answer, the only things you're combining are the 12y and the 10y. So 15y squared plus 22y. And remember, combining, you're no longer multiplying. So the powers or the degrees for the variables, they don't get added. You are now combining. So combining is just coefficients, keep the variable the same. It's the same as adding or subtracting. 10 plus 8. So this becomes a quadratic, 1, 2, 3, 3 terms, quadratic trinomial. Now I'm going to make this a little bit bigger just so that we can work with the other ones because there's one here that's a little longer than the ones we've done. So for ST8, you're still doing the same thing. You're going to work with distributive property and then combine. Same thing here, but this is a little longer. So remember, pause the video, get it done on your own, and then play the video to make sure you have it. And if you got it wrong, erase. You have an eraser. Erase and redo it. Just, make sure that you fix it. All right, so negative 3x times negative x squared, negative times negative, that's positive. And you're going to add the power of 1 and the power of 2. So that's 3, power of 3. And negative 3x times positive 3x, that's negative 9x squared. And negative 3x times negative 2, that's positive 6x. So classifying by degree and number of terms, highest degree is 3. Each one is a monomial, so we're good. It is a polynomial. So highest degree 3, that's cubic, 3 terms. So this is another cubic trinomial. There we go. And then this last one, this is the longest one. And this one, I am very picky about these things, very OCD when it comes to this. So I will probably write n plus 4 in the front just because this is the smaller polynomial. But you can always multiply however you want as long as you do it correctly. So what I would do is multiply the first term here times the first one. The order really doesn't matter. So that gives me n to the third. And the next one would give me 6n squared. Look, my handwriting is getting better. And n times -2 gives me -2n. So I'm done with n. Now I'm going to go to 4. 4 times n squared, that's 4n squared. I'm going to line it up with the next one. Then I have 4 times 6n, that's 24n. You're multiplying coefficients, combining exponents, adding exponents. So 4 times -2, that gives you -8. So look at the pattern here and look at the pattern here. So you see it, right? The first and the last terms, when you're multiplying, these things are very normal or they're similar. You're going to end up with a first and the last term that you can combine, and the middle terms you're going to be able to combine. So we're done with the multiplying part. Now we're just going to combine, bring it down. First term and last term have no like terms, so those stay. N to the third and -8. The middle is what you're going to combine. But remember, you are no longer adding exponents because this is no longer multiplying. You are now combining. So it's combine coefficients, keep exponents and variables. So 6n squared plus 4n squared is 10n squared. Think about it at the n squared, for example, as apples. If I have 6 apples and 4 apples, I don't have something else different for apples. I have 10 apples. It's still the same thing. So you don't, when you combine, you don't add the exponents. And then this is just 24 minus 2 and keep the n. So that one's going to give you 22n positive. So now to classify this one, look, we have 1, 2, 3, 4 terms. Each one is a monomial, so we're good. Highest degree is 3. Because the highest degree is 3, this is cubic. But because you have 1, 2, 3, 4 terms, anything over 4 or over, we call it polynomial of, of 4 terms. So this is a cubic polynomial of 4 terms. And that is how you classify that. All right, guys. So remember to practice, practice, practice. That's how you get really good at this stuff. I'll see you on the next one. Have a great day.